Hello, everyone. My name is Marco. I am called Okramius on the internet. If you got to know me here, probably you like me. If you got to know me on the internet, you probably hate me. And that's because I'm a code reviewer, and I'm always angry at code. I never like what I see. That's actually my job. I get actually paid to rant at people and at their code. This is my avatar, Standard Super Mario, if you didn't recognize the name. I work for a company called Rove. We're PHP consultants, pretty much, and we pretty much help businesses develop applications or fix some very complex use cases that they didn't figure out. I'm part of the Eden Framework community review team. We pretty much maintain the framework, try digging out bugs, finding security issues, and so forth. And I'm the currently release manager for Doctrine ORM. I promise I'll release 2.5.1 somewhere soon. I'm sorry, I've been quite busy. All right, so for today, I was actually expecting to cancel my talk and instead watch this awesome movie, which came out a couple of days ago, which is really just amazing. But they told me that they already paid for the hotel and everything, and this is something else, so I have to actually talk about extremely defensive PHP. Sorry. All right, extremely defensive because I am an extremist. Extremist as in I take decisions that may actually make you slower developing, but I am an extremist because I became an extremist. I'm not like making myself explode. A lot of people here in Europe think that extremism means bad things. It's actually just a way of seeing things. But I became an extremist after maintaining software. I maintain too many software projects that do too much. A lot of projects that are just started from a simple idea and now solve every problem in the world. Okay? And that's pretty much because everybody wants the new shiny feature. Everybody. This is exhibit A. This is the feature creep. All right? So this talk is about aggressive practices. You may apply them, you may not apply them, you may like them, you may not like them. They work really well for very long-lived projects. If you have a project and you want to make it live for 20 years, then maybe you want to apply this stuff. Otherwise maybe it's a bit too much, but I mean, it's up to you. I think that open source should apply this kind of practices because open source is pretty much throwing it out there, and then you don't know when you're going to maintain it next time. Because to be honest, nobody's getting paid to maintain software that is open source, or at least some companies do that, but you don't know when you're gonna do that. So know your limits, know when it's good to do this, know when the client is just going to ask you, why is this not done yet? So you don't really need to do this, but please be considerate about what you throw out there, because I'm going to hate you also for that, okay? All right, let's start with a bold way. You're dumb. Okay, no, I'm sorry. No, I don't mean you, okay? I'm sorry. I am dumb. Okay, actually, we are dumb. We as developers are really dumb. We're stubborn creatures, strange animals that build stuff, are really proud about what they build, and then say that they are right and the others are wrong. We are dumb, okay? And we are dumb as developers. We're dumb as people, we're dumb as humans. As any other animal, we have a very limited sight on what we're doing right now, what is happening around us. So everyone is dumb, okay? To some limit, everyone gets dumb. Those who don't admit that they're dumb are the dumbest, all right? So is anybody here familiar with the concept of defensive driving? Hands up. Couple of hands. Right? I guess I saw a lot of nervous driving. It looks like Italia here. So defensive driving is pretty much assuming that somebody else is going to do a mistake. And you're going to have an accident or cause some damage or probably do something really bad just because somebody else made a mistake. So defensive driving is pretty much thinking ahead, 3 seconds ahead. You always keep distance from the other car. You always expect an animal to jump into the road. You always expect that an old woman will come out of a corner and walk in the middle of the street, or a child will throw a ball in the middle of the street, and you're going to have a bad accident. This is defensive driving. And this is what happens with software as well. You build your stuff, it goes really, really nice, and then somebody uses it wrong, and some project explodes, and you get blamed, and you get all the infamy and whatever. It's not about blaming. It's really just about not making it explode in the first place. It should not happen. So defensive coding is like defensive driving. The idea is very similar to that. I'm going to show some techniques. It's not really a technical talk. It's more about the concept behind it. But that's pretty much what defensive coding is like. So you should be cautious about code written by everyone. Everyone means also you, okay? You in 6 months are a different coder. You're not the same person that wrote that piece of software. You don't even know that you wrote it, all right? That happens all the time. You do get blamed. Who is this idiot? Oh, oops. Happens all the time. Some references. There are some books that you may read if you didn't read them already. They're pretty much classical books. First one that I suggest is Code Complete 2. Well, second edition, not 2. But Code Complete is pretty much a set of practices on how to code, how to prevent mistakes, limits that you should impose yourself. It says pretty much basic stuff, such as don't have 40 parameters on a method, and don't write 2 pages methods, stuff like that. The second book that I really liked, and I actually read it when I was in high school, and I still remember a lot of it, is Effective Java. I know it's a Java book, but this book teaches you what you should not do. It's not about doing things, it's about avoiding things. That's a really interesting thing. That's the only thing that I actually learned at university, what not to do. So, and the other thing that you should be aware of is an industrial design concept. Industrial design is very, very aware of defensive design, and it's Poka-yoke. Poka-yoke applied to code and applied in the industry pretty much means avoiding mistakes. Poka-yoke comes from Japanese. I don't remember the exact transliteration and explanation, but pretty much it's foolproofing, okay? You are preventing a fool from breaking your system, okay? So a good example of a Poka-yoke is this one. Everybody knows what this is. This is an RJ45 connector. Has any of you ever managed to plug it in upside down? Right? You managed! All right, I don't have an elephant with me, but you would win one. So you can't really plug it in the other way around. What you can do is you can always build a netter killer and make your sysadmin very happy, but I suggest you avoid that because you can pretty much do some serious damage with that. It's fun though. You pretty much take a 220 volt thing and plug it into this one and then plug it into a server, and you see all the routers around the line pop. It's kind of fun. The other thing that I don't like, this is bad design in my opinion. This is a 4-dimensional space device. You plug it in, doesn't go in, turn it around, plug it in, doesn't go in, plug it in, turning it around again, and it works. So it must exist in a 4-dimensional space. So this is not such a good design. Despite it actually works, it's probably just because it's harder to destroy than an RJ45 cable. But this is probably not so good design. I could probably find other examples, but this was fun. So let's make one concept clear about code. And this is something that I heard a lot today, and I disagree very much with it. And that, well, everyone says that code is reusable. Who says that code is reusable? Can you raise your hands if you think that code is reusable? All right? I see a lot of hands, actually. So the point is that code is not reusable. Code is not reusable in first place. That is something that I realized too late in my developer life. Code is crap. Code is poop. You wrote it, it's legacy. And 90% of everything anyway is crap anyway. Okay? This is Theodore Sturgeon commenting. Commenting on some science fiction books. I think, I can't really remember. I grabbed it from Wikipedia, so I'm faking my knowledge about it. I'm looking very knowledgeable here, but I'm actually really ignorant about it. So, abstractions are reusable. Code is not reusable, just the abstraction is reusable. You rely on the abstraction, you don't rely on the code, exactly because the code is going to break, the code is going to change, the abstraction should not. Okay? Don't write crap, don't write code. Okay, the idea is avoid writing code whenever it's not needed. Code for your use case. Whenever you have a reuse case, just write another piece of code. Don't modify the existing code. This is the open-close principle, pretty much. All right? Okay, so let's get a bit more practical. Enough ranting. Now going to show you stuff that you can argue about. You can throw stuff at me. You can insult me on Twitter. Then we can insult each other all day. And we can have fun. All right. Assuming solid code. First of all, I'm going to assume that you already know what solid code is. So I'm not going to go over solid techniques. This is something that I think Brandon is going to talk about later on. I'm going to assume that some of you know about object calisthenics, and assuming that you're already implementing them to some level. It's also an extreme practice, so it's not applicable to every kind of project. But let's start from something very simple. You saw it a lot today, yesterday in the workshop. For those who were in the workshop, make state immutable. Immutability is a hot topic right now that functional programming languages come around this much. They pretty much had a renaissance, but it greatly simplifies your ability to reason about problems. You create an object, it's never going to change, which means that after it was created, you will never need to debug it, never need to think about all the flow and the changes of something inside the code. This simplifies your way of thinking about code a lot. And actually, PSR7, which is the new interface about HTTP messages released by the Framework Interoperability Group, I can't pronounce that, is actually getting it right. Every time you modify an object, you get a new object, which is kind of neat. It's helping a lot. You will hate it at first, but when you actually get to debug it, you will love it a lot. All right, so what about performance in immutability? Well, a lot of people argue that since everything is immutable, you're going to have a lot of variables, a lot of garbage collection. That is true. Especially in PHP, it's not that efficient to have everything immutable. I actually wrote the code for the some challenge before. If you didn't, it's actually fun to write it. And if you don't write it with immutable code, I can tell you it's a mess. It's very difficult to debug it. So what about performance? You have to profile, profile, and profile. Don't come and tell me, oh, I'm not going to do it immutable because it's unperformant. Write it first, then profile it, then prove that it is unperformant. And anyway, it's unperformant only when you reach a case where the big O notation is related with the amount of records involved. If you have an ON or something lower than this here, then you're probably telling bullshit anyway. Since we talked about no state mutations, the next involvement in that is obviously you avoid setters. I'm talking about basic stuff here, okay? I'm just telling you not to do something. You're still free to do it and shoot yourself in the foot, but this is pretty basic stuff. So setters don't mean anything anyway, okay? They are not object-oriented code. It's not a message that you're transmitting. You're sharing state between objects. It would make no difference between having a public property and a setter. Yes, you can apply some filtering. That's the typical excuse. But it doesn't really mean anything. Yeah? Setting some kind of implementation on something doesn't mean you're doing any work. You're just setting up things. And this brings me to counter-argument to something that I already argued with Rob. I'm not sure about today's talk of yours, if you mentioned it. I'm sorry, I was actually doing the challenge. But you prevent any point of injection that is not the constructor. We're talking about services here. We're talking about structures that involve computation. We're not talking about data structures. But in general, the only injection point for anything that is a service-ish structure is the constructor, and that's it. So you don't have any uninitialized properties, ever. You don't need to track any state that is lazily initialized. This is something that other tools solve. I tried to write some. You probably dislike those as well because they're magic. But still, it's not your problem. And the concept of optional dependencies, in my opinion, doesn't really exist. So what we have here is just a typical example. We have a connection, then we have the ability to set a logger on it. We want to log SQL queries. Just an example, very typical. And the logger may be optional as well. So if we don't set the logger, then it's not going to log anything. You can pretty much refactor this out very simply. And what you do is you don't make the dependency optional. Say, for me, they don't exist. It's my opinion anyway. What you do is you always require logger, regardless what it is, and you always inject it. And if your logger should not log, just inject a fake logger. Logger mock, logger null logger. There's a pattern for this, which is pretty much the null object pattern, which is about covering all these use cases. So, since we have no setters, we have no mutation, we have removed a lot of the operations that we usually apply to our objects, we start removing things. We're going pokayoke. That's the direction where we're going. We're going to remove things so that people can't plug it the other direction. Okay? Can't plug it wrong. So what we do is we remove unnecessary public methods. This involves anything that can be refactored in a different way. Okay? If you don't need that public method and you can code it in a different way, then you don't need it. This is unnecessary for me. It's a very extreme way of seeing it, where I'm removing utility methods and methods that are helping you simplify operations, and instead I'm replacing them with operations that are more expressive, or operations that do less but follow the single responsibility principle in a stricter way. And I like this quote from Stefan Priebsch. The idea is that a public method is like a child. Once you wrote it, you're going to maintain it for the rest of its life. Okay? And it's very, very true. Once you wrote a public method, it's so hard to get rid of it. Try removing a public method from any major framework. They're going to tell you, no, you can't do that. You're going to wait 4 years, 5 years until the next major release. And even there, they still have to discuss it first. All right? You avoid logic switch parameters. Logic switch parameters, I don't know if that's the name, actually. I didn't bother looking it up. I was a bit sleepy. But the idea is quite simple. You had a spammer class. It's a very bad spammer. And the spammer sends an email. It includes a template, and it eventually sends an opt-out link or not. So this guy is even illegal, but whatever. This is what many, many companies actually do. I guess everyone is familiar with the typical Nigerian spam emails. So you can't really opt out of it. I looked for the link. But what you do is you simply get rid of this parameter, which is doing a logic decision outside the context of the class. And instead, you code it as two methods. One that sends the illegal spam, and then the one that sends the apparently legal spam, okay? It's pretty much doing the same decision, but you're doing it up front. And if you go further, you can pretty much split these two and make a legal spammer and an illegal spammer, okay? You shoot two guys in one shot, all right? So, further on, we are pretty much just digging out problems with our code. All states should be encapsulated. This is pretty basic object-oriented programming. Does anybody see the problem with this piece of code, except that it is a setter? What's the problem with this piece of code? Come on. It's very simple. I didn't write any bug. This is actually something that many of you write, but there is a basic problem. Sorry? It isn't immutable, correct. That's what happens. This isn't immutable. So what happens is I'm injecting a datetime instance, which is passed around by reference. So what happens is, and by the way, the examples are simplified on purpose. What happens is that I build my current time, then I have a bank account, because every slide has a bank account, right? I have a bank account, I set the last refresh, and by the way, banks always use WordPress for writing code. Bank account 1, set last refresh, current time. Bank account 2, I do the same. Then some stuff happens in between. And then at some point I modify, for whatever reason, maybe 2 years after I wrote the code, I modify this, and suddenly I modified my bank accounts all in one shot. I have transactions at a different timestamp. Well, this is the kind of bug that you don't want in production. It's very hard to find out as well. So it's very simple. You pretty much take the datetime object and clone it, because datetime is not really a value object. And the actually correct solution is simply use a datetime immutable instance, which pretty much encapsulates this problem and saves you the hassle in first place. And the same, by the way, applies also for the constructor. So we have a money transfer, we have an amount, and a transfer, and we are assigning it, and this is not immutable, so it's affected by the same bug. The same solution applies here, so we're going to clone, and eventually we can just use a datetime immutable. Or you can use your own value objects, because a datetime doesn't really mean a lot here. You probably want to transfer a date instead of a datetime instance, which goes back to what Matthias was saying about type safety of identity. All right. For me, external access to state includes also the subclasses. Every time you write a subclass, you're pretty much writing a new use case for whatever you're writing. I wrote an article around it, but in general, subclasses are external entities trying to access your state. So my suggestion is to always make everything private. This is something that in the Symfony world is already quite accepted. You make state private by default, make private properties by default. You make them protected only if you really have a use case. And to be honest, I see less and less and less of those. You really have a hard time finding use cases for protected properties. And also you assert a lot of on what is passed in and what goes out of your objects. So whenever you get some state changes, whenever you get some state passed in, you want to verify all the state and verify that it follows your rules. So you enforce very strict invariants on your code. And this pretty much means that you apply some static validation. So what I'm doing here, if anybody can follow this, because it's PHP 7 code, what I'm doing is I'm implementing some kind of variadic way of validating an array. So what I have is I have a train, and a train has wagons. So I'm expecting here an array of wagons. Okay, so what I do is I build a closure here. This closure expects a list of parameter of type wagon and returns them. And I use the splat operator to explode the array as a list of parameters. This is just a nice trick to avoid some very expensive looping operations and some very array mapping operations. But yeah, there's better ways of doing this. This is not nice. It works. It's just some kind of strict validation. It works only on PHP 7. If you're not insane like me, you're going to use this thing, which is beheberle assert. There's an assert library, or pretty much API, also in PHP core, but I prefer this one. It's much simpler. It's in userland, simpler to debug, and you pretty much can also extend it, which is not that bad. And you can just use it. All right, so since we validate on state, we also want to ensure that this state pretty much travels around in our system and keeps a valid consistency. So we avoid any mixed parameter types, mixed return types. So here we have an example. We have a prisoner transfer request. So we're probably transferring a prisoner from a place to another. I'm not good at happy examples. I'm always picking something sad. I'm sorry. So you get some access level to this request. You want to approve this request with some access level because you want to know what you need to transfer this client, this prisoner. So you have false. If you can't, you get true. If some guards are required, then you get null. If it can't be decided, you get 10. If a special cargo is required, and 20 if a high security is required. What? Really? Okay, so pretty much this is something that happens a lot in code that evolves with time. You start adding parameters and use cases to it. You modify the code instead of rewriting it. So what you do in this case is very simple. You pretty much encapsulate everything into a value object here, and those rules are encapsulated, and then you treat them there. So now your object travels around the system and keeps consistency. So value object for the win. Value objects ensure this consistency. They prevent you from doing silly mistakes. They encapsulate some immutability, which is good. They validate your data. It's also good. And in general, so you can pretty much send a register with an email address, with some kind of email address. You put the validation of the email address in the value object. You forget about it. You use type hinting for pretty much moving the object inside your system. You don't need to revalidate it all the time. You have to use it. So, no parameter types of type mixed, no parameters, no return types of type mixed. This is pretty obvious. I didn't really make an example, but you just return a value object, and that's simple. A good example for this is validation APIs. Think about the Symfony validator or the Zen framework validator. Zen validator is probably used a lot more in this case, but if you take a Zen validator, what happens is you call the validator and say, is some particular value valid? And then it says yes or no, says true or false. So the return type is Boolean. But what happens if you have to ask for an error message? What was the validation error? Why is my email address not valid? Okay, so what you do is you ask the validator again, sorry, I forgot. Can you please also tell me what the validation error was? And so you're getting back at the validator and asking for a different value, so your validator is now stateful. So you pretty much solve it the same way. You pretty much return a validation result from your validator, and it says, yes, it's valid, no, it's not valid. It says, these are the error messages. This was the value that I filtered. This is the value that I actually validated, and so on and so forth. Okay, you avoid fluent interfaces. So now I want you guys to figure out what is wrong with this example. So a fluent interface allows you to use this approach, pretty much chain method calls. It allows you to do this, you assign and call, which is the immutable style. And it allows also this, so you're calling directly on the object. Can anybody tell me what's wrong with this approach, considering what we talked about? Mutable, kind of. Semicolon. Oh, yeah. Nice. Yeah, this happens when you write slides at the last minute. Okay, now the problem is that this is not Poka-Yoke. This doesn't follow Poka-Yoke. You have only one way of doing a thing. Why do I have 3 ways of coding the same code? I personally don't believe in freedom in coding. The more freedom you remove from the code, the better it's going to be for pretty much everyone. You can always add it later, okay? It's not like I'm jailing you. You can always modify the code, change it, but reduce the number of ways that you use to make one single thing in your code. So you simply allow this, period. Return void. It's perfectly legit. Okay, yes, this is a mutable API, but maybe it's causing some side effects, whatever. Okay, there's a blog post for that. I listed all the possible ways in this world to break an immutable or a mutable fluent interface, so go read it eventually if you're not convinced about it. The other thing that you will probably not like that much is that you can make classes final by default. As I said, an extension is a different use case, and you're trying to reuse some code from the parent class. Okay? So you don't really need that. Just code a new class. And to be honest, and this is something that everyone will like go, whoa, copy-paste is better than extends. Okay? Just copy-paste. I'm serious. Copy-paste is better than extends. It's going to cause less coupling. It's going to cause you less problems in the future. And you just have stable code. Yes, you will have double the bugs, but you can always solve them in more locations at once. And if you have duplicated code, in a lot of code duplicated between 2 classes, then it means that you probably didn't apply composition very well. Your class is maybe doing too much. Okay, so copy-paste. One way to see this is take your class, convert it to an interface, then take this interface and try to extend the interface. Okay? Does your extended interface add any meaning? Does it have a different meaning? Okay? If you don't find a way to say, yes, this new interface is actually a specific type, and it has this new additional meaning, then you probably don't need the extends keyword. Okay? You don't need extends if you cannot find a meaning. Not everyone is animal, mammal, cat, and my kind of cut, whatever it is. Okay, it's not like that in the real world. Okay, and there's again blog post for that. If you want to argue, fine, just throw shit at me on Twitter, it's fine. But go read it first, right? Okay, other things, these come from more from Java and from the Java books around the topic. Ensure deep cloning. A lot of cases of bugs that I saw when using clone come from not cloning all the private members that are referenced by ref. So whenever you clone something, you need to ensure that all the private state is cloned as well. Otherwise, you're going to have some very, very funny bugs, same as the one with the bank account that we saw before. And as well, you're not really sure if you should use the same instance for applying more logic, all right? So cloning requires you also to understand the encapsulated state. You're trying to also clone all the dependencies, so you're assuming that they are also clonable. And this assumption is kind of broken because the entire idea of assuming things when there's no interface for it is kind of broken. If you don't have an interface for it, you can't assume that it will work. So, extreme, disable cloning. Add this to every class? Well, probably not. But you probably just want people to stop doing that. You throw an exception. Why would you clone me? It's currently legal. Is it human? I guess it's currently illegal. Sometime it will become legal, maybe, I don't know. So the same you can apply to serialization. Is your class really serializable? Do you know the life cycle of every dependency? Do you know the lifetime of every dependency? Can you actually represent your class as a string somewhere? Does it make sense? Okay? Is your user representable as a string in your system? Or does it need to be somewhere in a more normalized way? So again, same thing. You just implement the sleep method. Yes, we're using PHP magic. You throw an exception and say, no, you're not going to get me as a string. Serialize maybe only those things that are serializable. There's libraries out there making closures serializable. So you can serialize your bugs and unserialize on the other side and run your bugs on a different system. That's interesting, right? You can commit your bugs to a concurrent version system or whatever. All right, unit testing. And I promise I'm almost done here. Test all scenarios, okay? You're not assuming anything. You're not assuming that the code will work. You're assuming only what the interfaces tell you. Nothing more, nothing less. So you test all of the use cases, which means, yes, I know it's kind of contradictory, but 100% code coverage, and you need to get a crap score of less than 2, which pretty much means that you're covering every possible path in your code, and there's one test for every path, which is kind of annoying. It will make you cry. You will implore for less features. You will be happy when your code has less features. You will be so happy that somebody says, no, it doesn't need to do that, okay? So we'll start writing smaller and smaller classes simply because it's so complicated to test them otherwise. So here's an example. We have an out service. The out service returns a Boolean. It throws an invalid argument exception in some cases. We don't know which ones. We can't assume it. It's an interface. It doesn't tell us more than that. It throws an incompatible credential exception. It throws an unavailable backend exception. Okay? And it still follows all the principles that we described so far. Okay? And then we have some code that uses this interface. This code is just making a login. It depends on this authentication service. It's a dependency in here. We authenticate with some basic credentials, and we return either true or false, and here is some other code that has to be executed, which is our actual logic depending on whatever here. So what can happen here? What can go wrong here? So the fact is that a lot of people don't test some of the cases here. So can anybody tell me how many tests we should write here? 5. Yeah, 5 is correct, actually. Yeah. So what we do is we code the cases for our conditionals. Okay. I know that we're testing here unit testing very old style, as in we're looking in the box and making sure that every path is covered. So Boolean true, Boolean false. We tested the invalid argument exception. Even if it's just bubbling up, we know that we rely on it, so we should not catch it. We know that we're not catching it, so we test that we're not catching it. Incompatible credential exception, unavailable backend exception. This is stuff that in more strictly typed languages doesn't need to be tested because the type system checks that you're not catching it, so you should document it or annotate it accordingly. So such little amount of code, already 5 tests. So to recap, all these are just suggestions. There's more of those. I didn't list many of them because most of them are related to transactional code, which goes very into database and complex use case scenarios. It goes into threads and stuff like that. But these are suggestions that I'm giving you. But in general, you trust nobody. You trust no code. You don't trust yourself now. You don't trust yourself in a week. You don't trust yourself in 6 months. Okay? You reduce features to the bare minimum. The single responsibility principle is not about, yes, I have more paths in my code. No, it's really about features. Your code is doing too many things. You ain't gonna need it, right? If you don't need it, don't code it. That's pretty much the idea. Code is buggy up front. You have very strict invariants. You expect strict things. You expect them to be immutable whenever possible. And you return strict things. Okay? Reduce the amount of decision paths done by a consumer of your APIs. And that's it. Thank you.